G'day cobbers, welcome back to the bush. In this episode of Lockyard's Four Driving, we're looking at reseating tyre beads with a couple of different propellants. Is it safe? Should you be doing it? Or should you just be using an air compressor? Let's get into the video. Now let's check out the propellants I've chosen to use. These are the sort of cans you'll probably find kicking around the back of your four-wheel drive. Firstly, deodorant, and then a water dispersant spray like WD40, and finally, because everyone's got a mate who drives a GQ Petty, it's a can of Start You Bastard. Okay, let's check out the setup. So we've got a regulated 5-volt power supply here, feeding 5 volts to this pressure transducer. Now the pressure transducer outputs a certain amount of voltage depending on how much pressure it's seeing from the tyre valve here. At the moment, because she's debeaded, not too much, about 0.5 of a volt. That's then fed back into this USB oscilloscope. Now the USB oscilloscope then feeds a laptop and outputs to the display there. Now I'm sure you're not all familiar with the USB oscilloscope and how they work, so let's have a bit more of a deep dive into how the oscilloscope works. And here's the screen to my USB oscilloscope. Now a lot of people are intimidated for some reason by an oscilloscope, and look, I don't know why. I should have bought one years and years ago. All they are is a graphing multimeter that only reads volts over time. Now you can see the zoom horizontally here, and that's in 100 millisecond increments. So in between here and here is 100 milliseconds, or 0.1 of a second. In between here and here is 0.1 of a second, and so on and so forth. So to get from one side right through clean to the other, it is 1 full second. And again, the zoom horizontally, and this is only channel 1 active at the moment. This oscilloscope's actually got 8 channels. So in between here and here is 1 volt. In between here and here, 1 volt. So it can measure on this setting a maximum of 4 volts positive and 4 volts negative. And you actually move this around if you like. It's very versatile. So if you want to measure 8 volts in this setting, you can start from the bottom there. Okay, so we'll put it back on the 0 line. Now what I'm going to do is I'm going to turn on my reference 5 volt power supply that'll be running through my pressure transducer. Now when it's got no pressure or atmospheric pressure, it can read about 0.5 of a volt, and you saw it just head up there. So what I'll do is I'll put my cursor on and we'll actually be able to measure that. So I go to cursor and I'll go to type and I'll go to cross. In between this point here and this point here, the 0 line roughly, there we go, 500 millivolts or half a volt. So it's putting out about half a volt when there's no pressure on it, or just atmospheric pressure. But what about when you want to set up a trigger? Let's have a look at that. So firstly, I'll cancel this cursor back to none. And what you want to do, and this is one of the great benefits of utilizing an oscilloscope, is you can set up a trigger. Now the trigger, obviously you want to start at the start, so we're going to drag the trigger start right to the start there, and you can set up the trigger height. If we set it above that baseline there, it's not going to actually trigger and start recording until such time as the voltage gets above that base voltage, until the pressure sensor is experiencing a pressure above atmospheric. We'll set it to single, and we'll set it to wait. Okay, now the pressure transducer is waiting for a pressure above atmospheric before it'll start recording. Now I'm going to breathe into the pressure sensor and see if I can generate enough pressure in order to set off that trigger. And here we go. Though I've got no hope of generating 300 psi, you can see we've actually now set off the trigger and it's stagnant, and it's going to stop there until such time as we can generate a CSV file, a comma separated value file, which we can then further analyze in something like Excel. So you can also do a screenshot and measurements. Okay, what I'll do now is I'll put up a screenshot from one of the tests so you can have a look. And as I said before, now you're looking at this screenshot, I've generated CSV files, or comma separated value files, which I can then put into Excel and generate those graphs that Ed from Ed's Camping and Four-Wheel Drive Adventures loves so much. Good on you, Ed. Anyway, so that's the very basics of how an oscilloscope works. And look, if you're into automotive and you like messing with the electronics, especially in automotive, they're just so cheap these days. Get yourself an oscilloscope. It opens up a whole new world. And now we know a little bit more about how the oscilloscope works. Let's check out the chemical properties of a few fuels. Petrol E85, butane and ether. Now, I'm not proposing for 1 second that we either use petrol or E85 in order to rebead tyres onto wheels. That's way too dangerous. But butane is a very common propellant in aerosols, and the ether, of course, is in Start Your Bastard. Now, we're going to look at, firstly, LFL, stoichiometric mixture, and UFL. Let's define those terms. LFL is the lower flammability limit. So that's the minimum percentage of fuel in air that will actually light up. Stoichiometric mixture, or commonly known as stoic, is the optimum amount of fuel to air where all the oxygen in the air is burnt up. And UFL is rich. So that's the maximum amount of fuel in air which will actually light up, beyond which there's not actually enough oxygen for it to ignite. Okay, first up, petrol. 1.4% is the lower flammability limit, or LFL. Stoic is 6.8%. Now, you might have heard that stoichiometric ratio for petrol is 14.7 to 1, and that's correct. So it's 14.7 parts of air to 1 part fuel, and that works out to 6.8% fuel in air. Now, the UFL is 7.6. Let's move on to E85. 3.5 for the LFL, stoic is 10.2, and finally UFL 15%. Butane, so this is your common propellant that's used in a lot of aerosols, 1.9%. 6.5% is stoic, and finally 8.4% is the UFL. Now, ether, 1.9%, so very similar again, 9%, a little bit richer but not a lot. And finally, UFL. Now, the UFL is interesting in this one. 36%, which is much higher than any of the other fuels. Now, the great thing about having a high UFL is if it's really, really rich, well, it's still going to light up. So that's why people use ether in a product like Start Your Bastard, because it can be still really, really rich, and it won't flood like petrol will down at 7.6%. It has to get up to 36% before it won't ignite. And that's a great thing about ether being used in a product like Start Your Bastard. So the next chemical property of these fuels I want to have a look at is lower and higher heating values. Now, the higher heating value represents the amount of energy released when a fuel undergoes complete combustion, but the resulting water vapor from that combustion remains as a gas, in comparison with a lower heating value, which represents the amount of energy released when a fuel undergoes complete combustion and the resulting water vapor condenses back to a liquid state. So that takes energy. So always the lower heating value is going to be slightly less than the higher heating value. Let's check out the results. Firstly, petrol. It has a lower heating value of 44, that's in megajoules per kilogram, and a higher heating value of 46. E85, 27.5 for the lower heating value, and for the higher heating value, 28.5. Next up, butane. 51 is a lower heating value, and the higher heating value, 52. And finally, ether, lower heating value 28.5, and the higher heating value just above that at 29. And now we know a little bit more about the chemical properties of the various fuels. Let's start the testing. So first up, we're going to try the deodorant. Now, in between each and every test, and I'll be conducting each test 3 times, I'm going to run some air into the tyre for about 30 seconds or so to make sure I've got clean and fresh oxygen each and every time for consistent and accurate results. Righto, so we're going to put about 10 seconds worth of deodorant into the tyre. And the USB oscilloscope is already set to trigger mode, so it's ready to record, and let's give it a go. And we're actually getting a little bit of suction there. Now let's check out that result for rebeading tyres with propellants using deodorant. On the left hand side here we've got the pressure and PSI ranging from 0 right through to 90 PSI, and the blue of course will be the deodorant. Let's check it out, and that's in real time. It took a second to take this measurement. Maximum 85 PSI. But what about WD40? Let's check that out now. And now you've seen the results for deodorant, let's try WD40. So I've cleared out the air in the tyre. I've got the oscilloscope on trigger mode. Let's give it 10 seconds, see if we can light it up. Okay, that doesn't seem to be working. Let's give it a few more seconds. Okay, let's give it a final go. No, well, that one doesn't seem to be working. So it doesn't look like WD40 is any good for reinflating your tyres using a flame. Drop a comment down below if you've had any luck using the likes of WD40 to rebead a tyre, because as you just saw, I didn't. Righto, let's move on to Start Your Bastard. Let me tell you, because of its chemical properties, I'm more than a little concerned about this one, but you know, science. All right, 10 seconds. Righto, let's light it up and see how we go. Well, that was pretty energetic. Okay, so we'll do that a couple more times if my heart's going to stand it, and we'll check out the results. Now let's check out the result of Start Your Bastard, and that's the orange trace there. Now the first thing you'll notice is the maximum pressure was actually 2 psi less for Start Your Bastard than for the deodorant, and that really surprised me considering the violence of the rebeading process with Start Your Bastard, and that can be contributed to the gradient of the graph here. The pressure rose a lot more quickly with Start Your Bastard with that ether content than that of the butane content, primarily attributed to the deodorant inflation. But there's one more test I want to do. Let's check that out now. The astute amongst you would have noticed that during the testing, this second valve here didn't actually have a valve core in it, and the problem I was facing was the cores, not the actual Schrader valve, but the cores kept popping out. Which is a sign of exactly how much pressure we're dealing with. But you can't go through all the testing without trying it at least once. So I'm going to give it a go with deodorant, because that seems the least violent of the two viable options, and we'll see how we go. So 10 seconds of deodorant. And the oscilloscope's already set to go. Let's give it a crack. I'll stand well back for this one. Now, when I've seen this done on video, what usually happens is after a little while, it actually starts sucking back in. So we'll see if that happens. So it's kind of hard to see in the video, but it's actually concave here as opposed to convex. It's sticking in and it looks like it's about to come off the bead. I'll give it a couple of whacks. No, it's not coming off the bead, but I tell you what, it's not far off. And I can see why people put the air compressor straight on the valve as soon as it pops. So let's check out the peak pressure. And here are the results of rebeading that tyre using deodorant with that Schrader valve intact. Now, you'll be able to see the peak pressure for starters. It was only 4 psi above the deodorant with no valve. So not a lot there. But what you will notice is the gradient of the graph. It's very similar to the ether-laden Start Your Bastard. So that contributes to the violence of the inflation when you've got the valve inserted. Okay, now surprisingly, the peak wasn't all that different. I thought it would be with the valve core in comparison with deodorant with the valve core out. So what do we think in the end? Well, the deodorant, it seems reasonably reliable, and surprisingly, it didn't exceed the peak pressure which I've tested these tyres to, which is around about 300 psi. There's a link up above there. WD40, well, that was a bit of a fail. Start Your Bastard, well, that certainly got the tyre started back onto the bead, but also scared the bojingos out of me in the process. So, our preference, Rexona, as to whether we'd do it out on the field, look, preferentially I'd still do it with just a decent air compressor. But if you're stuck and your air compressor's not doing the job for you, well, perhaps get out your Rexona and give it a crack. All right, guys, now if you like this video, don't forget to give it a thumbs up, and if you didn't, by all means, give it a thumbs down. Not once, not thrice, but twice. Thanks, guys. We'll see you in the next one.